Great. And with that, Camilo, go ahead and take it away. And if you want to turn on your camera, all yours.
All right. Can you hear me?
Yes, you're coming in very clear.
Awesome. Yeah, so let me start by just introducing myself also. So I'm Camilo Zapata. I'm an engineering manager at Landing AI. And yeah, today I'm going to be talking to you about OCR, specifically deep learning-based OCR models. And we're going to do a technical deep dive. Basically, let me walk you through the agenda here. So first, I'm going to do a very, very brief explanation of what deep learning-based OCR is. Then I'm going to teach you also very quickly how to use Landing AI's OCR model. After that, I will explain to you what problem we're going to solve today. So I prepared a demo using Landing AI's tools so that we can see how to actually put in practice the knowledge about deep learning-based OCR and learn how to use it, how to integrate it into an application. So yeah, I will explain to you what the problem will be. Then, of course, I'm just going to go directly to the code. I prepared a Jupyter notebook with the demo that I will give today. So I will go to the Jupyter notebook. I will walk through the code with everyone. I will show you what I built using Landing AI's tools. Basically, I created a little bit of an airport control tower. It's a pretty simple demo of how you would go about building an airport control tower remotely. And then I'm going to talk about applications of OCR in other sectors. So yeah, let's start right away. So first of all, what is deep learning-based OCR? So deep learning-based OCR, is optical character recognition. So in a few words, basically, you just want to detect text in images. In the past, OCR systems have existed for a very long time, many years. Before deep learning, these systems were built using special kind of handcrafted rules. So you had to code handcrafted rules to detect characters, to detect numbers. If you wanted to have a different language supported for your OCR system, then you had to go again and code more handcrafted rules for the different characters in different languages. So it was very brittle to environment changes, to the image environment, and to the font type. So that were kind of the limitations of the old OCR systems. New OCR models, they are mostly based on deep learning. The deep learning models, as most of you might know, basically you just have a bunch of data with characters on it or with text on them. It can be any language that you want, and then you just train a model with that, and the model learns how to detect this text in images. Some advantages of the deep learning-based OCR models are, for example, that it's very resilient to like a huge variety of environments, kind of different font types, different lighting, like different types of printed fonts. So yeah, so they're pretty much very sturdy when you compare them to the traditional OCR models. Yeah, so that's another advantage is actually that the new OCR models are able also to detect the position of the text in the images. They're able to tell you exactly where they are and draw kind of a bounding box around the text. It can detect multiple areas of text in the images. So they're pretty like a very big improvement to compared to traditional OCR models. All right. So next, I'm going to talk about some OCR applications. So OCR applications, for example, go through digitalization of printed documents, in logistics, for example, detecting text in the packages so that you can sort them and send them to the correct place. In manufacturing, you can have, for example, identifying the lot of defective parts. So let's say you have a manufacturing line. There's this manufacturing line produces, let's say some semiconductors, right? And you detect some defective pieces automatically with your visual inspection system. And then with OCR model, you can actually kind of read out kind of the lot of the part. And so that way you can automatically detect what lot is defective. And yeah. And then for monitoring, you can also, for example, read out physical gauges. So I don't know, let's say in your factory, you also have a thermometer on the wall, and you want to read out the temperature, like to monitor from a remote location, the temperature of your factory. So you can actually use a camera and an OCR model to read out the gauge for this. All right, so those are some of the OCR applications. Then using Landing AI's OCR model. So here in this slide, I mostly just pasted the code using the Landing AI Python package. So in the Landing AI Python package, we have an OCR predictor. You just input your API key from Landing Lens, and then pretty easily, you just load an image and run it through the OCR predictor, and you get back the text predictions. You can see here on the right side. This is actually an example that I ran yesterday with the OCR predictor. So this image, we're detecting all the text like Chinese and English, which is the languages that we support on the Landing AI OCR model. And it not only detects the text, but it also detects the position of the text in the image. So yeah, that's what you get out of the OCR model. Pretty easy to use, just a couple lines of code. Yeah, and then that's how you would use it. I mean, this is just a copy-pasted code, but I'm going to show you exactly how to use it when I go to the demo. All right, so what is the problem that I'm going to solve today? So today I prepared a demo kind of to build an airport control tower. This idea, let me talk to you a little bit about how this idea came to me. So I was watching some videos on YouTube. I saw that there are airports around the world that are actually doing this. They are planning to replace physical airport control towers with kind of remote control towers, where basically you just place cameras all around the airport, high definition cameras, pointing at all the important areas of the airport. And then you use computer vision models to detect the airplanes, to detect the supporting vehicles on ground. And with this, you basically are able to transmit all this data to a central operations center where airport controllers can control the comings and goings of airplanes or different vehicles. So I wanted to build kind of a very simple demo of how a system like that would look like. Yeah, so let's actually jump right to the demo. All right, so I have here a Jupyter notebook with the code. So yeah, just a very brief explanation again of what we're building today. So I found this data set in Kaggle. Let me see if I have it open here. Yeah, I have it open here. So it's a data set of commercial aircraft. Basically, it has pretty good definition images of airplanes. So I took a few examples from that data set. I think I took like maybe like 15 images. So let's load those images here. Again, I'm using Landing AI's Python package to load images from a folder that I have locally. All right, so loading the images. And then let me just iterate through these images to show you what we're going to be working with. All right, so yeah, these are the images that I got from the data set. First one, this Southwest airplane, this Delta airplane. All right, I'm going to iterate through this, but let me first explain what we want to detect, or more or less what the system will look like at the end of the demo. So we have these images of airplanes. Well, let's imagine that these are images coming from a high definition camera in the airport. So how would you go about knowing what this airplane is? Where is it going? Like what time is it leaving? So I think a good way to do this would be being able to read the registration number that is here in the tail, like near the tail of the plane. So if you can read that registration number, you can know exactly what that plane is gonna do by connecting to your airport systems. So that's what we're gonna try to do. We're gonna try to read a registration number from the planes. As you can see, yeah, registration numbers also come in different formats depending whether it's European or it's in America. Yeah, this Emirates plane, you can see here the font is very small. You can also see that the registration number is not always located in the same place. Yeah, you can see also, like for example, because of the angle of this camera, the text is kind of tilted. Yeah, so these are the images. You can see also color of the font changes sometimes. All right, yeah, you can see, for example, this is blue, like white font against a blue background. All right, I think these are all the images that we're gonna work with today. I think it's 15 images of the planes. So let's start with a pretty naive approach. We're gonna, I call this the pure OCR approach. So what we're gonna do is just, let's run these images through the OCR predictor from Landing AI. So you can see here, I loaded the OCR predictor here. And here, I'm gonna use it to predict on each of the images that I loaded from planes. Finally, I'm gonna also use the visualize module from the Landing AI Python package to overlay the predictions in the images. And in the end, I'm just gonna iterate over all the predictions and show you all what the OCR, like the pure OCR approach would look like to try to read out the registration number from the planes. All right, so we got our response back from the OCR model. You can see here, first image, Southwest plane. It is actually able to detect the registration number. You can see it here. I believe this number is correct. This readout is correct. You can also see that it detects other text, like here, Southwest on the tail. It also, like in this case, messes up a little bit, thinking that the windows are zeros. But yeah, but that's the problem of kind of having a very difficult image to work with for OCR. OCR is mostly thought about for printed documents or printed text in a controlled environment. So this is a pretty difficult kind of data set for the OCR model. Let's go through the images. Again, here, it's able to detect delta. It's able to detect the registration number correctly. That's pretty good. Here, also, it detects a bunch of text. It also detects the registration number on the tail. I think the registration number is also correct. But then we start getting into trouble, right? So for this Emirates plane, it actually is not able to detect the registration number. For this one, it detects correctly. This one too. This one detects a bunch of text. It detects the registration number, but actually this registration number that was detected is not correct. The readout here, it's not right. As I was telling you, this is a pretty difficult data set. So this image is tilted. Also, kind of the body of the plane is curved, right? So when you take a picture, the letters tend to be also deformed. All right, so yeah, I'm just gonna go quickly through the rest of the images, showing that sometimes it detects the registration number, sometimes it doesn't. Actually, here it didn't detect anything. Yeah. All right, here it also didn't detect the registration number. And this is the last image. All right, so I would say the model performs okay. It could detect the registration number in some cases, but it's not too good, right? Like we wouldn't want a system to work like this, where sometimes it works, sometimes it doesn't. Like the other thing that is actually pretty tough is out of all the text that was detected from the model, which one is the registration number, right? I would have to kind of try to sort out which out of all these texts that were detected is the actual registration number. That's also not a problem that is very easy to do, because as I was telling you, the place where the registration number is can be different from plane to plane, from airline to airline, even maybe from country to country. So it's very difficult to kind of try to extract the registration number with this pure OCR approach. So when I was preparing the demo, I was thinking, what can we do to improve the performance of this system, right? So I thought about basically chaining models. So I'm gonna give the OCR model a little help on how to solve this problem. So what I did was I went ahead and created in Landing Lens. So Landing Lens is the tool that we offer for everyone to train computer vision models. So you can train object detection models, where you basically draw bounding boxes on images to detect the objects that you want to detect, or you can train segmentation or classification models. So this is Landing Lens tool. So what I did was I actually took the Kaggle commercial aircraft dataset. I selected a few images. Actually, you can see here, it's 61 images that I selected for this project. And what I'm doing here is I'm not actually reading the registration number or training a model to read the registration number. I'm just training a model to detect where the registration number is located in the plane. So I call this the ROI, or region of interest. So you can see here a few images of the ones that I labeled. As I was telling you, I uploaded 61 images, labeled all of them by hand a couple days ago, kind of showing labeling where the registration number is located on different types of planes and different environments. Yeah, all right. So this is the data that I uploaded to Landing Lens. This data was already labeled by me. So it's pretty easy to train an object detection model. You just click here on train. I'm gonna go ahead and click it. All right, when you click on train, it starts training your model. So here, you're gonna start seeing the learning curve for an object detection model being trained, and then it's gonna go to evaluation. And in the end, it's gonna give you a model and predictions here on the images. But we don't have to wait for that now, because I already trained the model 3 days ago, which is this one. I thought this model was performing pretty well. So precision is 100%, recall is 78%, but I think for today's demos, that works okay. You could also actually see the mistakes that the model made in your data set. So I went ahead and deployed this model. So what I mean by deploy is actually we offer a cloud deployment for all the models that we train in Landing Lens. So I went ahead, deployed that model. That model is deployed now here in this cloud deployment endpoint. And now, like with the model deployed there, we can just go and use the Landing AI package also to make predictions with this model. So here, if you click on View API command, you can actually just copy this code to make predictions with your model using Python, the Landing AI Python package. For this example, I already have the code in the Jupyter notebook. So I just copy the endpoint ID. Okay, let me finish iterating here to the images. All right. Sounds good. Yeah. So I just copied the endpoint ID, which is this same endpoint ID that I have here. And with that endpoint ID, I'm gonna go ahead and do predictions with that model. So you can see here, I'm loading the predictor with the endpoint ID that the Landing Lens platform gave me. And then I'm iterating over all the images that I loaded, calculating the predictions with the predictor. Then again, overlaying the visualization of the predictions. of the images. And then finally, I'm just gonna iterate over the images to show you the predictions over this 15 image data set that I have here. All right. So it's calling the cloud endpoint to execute the predictions, and we should see predictions now. All right. So you can see, actually, one thing that I want to clarify is these images that I'm using here for this example, actually, they were not used for training. So these are images completely new to the model. So I was actually quite surprised that with very few images, the model was performing so well. So you can see here, the model was able to detect the region of interest, which is the area where the registration number is. Let me go through each of the planes. This one also detected correctly the region of interest. Here too. Okay, here, I don't know if you remember, but for this specific plane, the OCR model had not detected the registration number. So it's good that this model is able to detect the region of interest for this one too, for this one too. This one also pretty good. All right, let me finish going through the images here. This one also had not been detected by the OCR model, but now is detected with the object detection model. All right. All right. Yeah. So those were all the 15 images. I think this model actually performed really well for all those 15 images. It was able to detect all 15 registration number places or region of interest. And now with that, what are we going to do? So let's start just by cropping out the region of interest, right? So again, I'm just going to use this crop module, crop function from the post-process module. And just crop the images. You can see here the result. Basically, I'm just cropping the region of interest for each of the 15 planes. Everything looks okay to me. I think with this, actually, we're making the OCR job a lot easier. So we're just gonna take directly again the OCR predictor that we instantiated previously and run predictions over the cropped images, over the regions of interest. Then again, I'm gonna overlay the prediction and I'm gonna show you the predictions here in the output. Okay, yeah, so I run prediction with the OCR model. Now you can see actually this performing a lot better. I actually think that all of these registration numbers are correct. Yeah, even this one was the Emirates plane that was not detected by OCR previously. This is the correct detection. For this one too, correct detection. Yeah, so I think actually by chaining the two models, the object detection model that detects the region of interest and the OCR model, we're actually getting pretty good results. I think none of these registration numbers is incorrect. Yeah, all of these are correct. So now what can we do with this? So I told you at the beginning that the plan was to build like a kind of a demo of an airport control tower. So all these are supposedly images coming from my video feed from the airport. I am able to detect now the registration numbers of each plane. And now I want to integrate it into my airport control systems, right? So I'm going to take this registration number, I'm going to input it into the airport control system, and I'm going to basically see all the information about that plane. I'm going to see where it comes from, where it's going. I'm going to see where it is right now, and all that, right? But of course, I don't have an airport control system or information system. So I found online, I actually have the link here too. There's an API for developers to be able to get information about flights and planes and airports. So I went ahead and I'm trying to integrate that with our system. You can see here the code is not too complex. It's just a couple API calls to this API service. I'm basically getting the flight information, the aircraft information, and the airport information for these planes. So this, I have to be completely honest, I think there's going to be a little bit of luck involved here in this section, because of all those images that I have been showing you, I don't know which of these planes are currently flying, if any. I tried to select some planes that I knew were currently flying at this time, but let's see if it works out. Yeah, so basically, I'm getting all the flight information, aircraft information, departure and arrival info, and then I'm using Plotly just to plot that in a map. So okay, let's see which of these planes are currently flying. All right, so we have this Southwest plane. By calling these APIs, I'm actually able to plot here in this world map where the plane is right now. So it's telling me that it departed the Green Airport. Honestly, I don't know. It looks like the east coast of the U.S. And it's going to Ronald Reagan Washington National Airport. And it's actually about to land, probably. It's very close to the arrival airport. So yeah, I mean, this is pretty nice. I'm able to kind of get these images. Probably this image of this plane was taken years ago, but I'm now using it to see what it is right now, which is very, very nice. Let's see which other of these planes is currently flying. All right, this Delta. This Delta is also is going from Detroit to San Antonio International, and it's also probably about to land very close to the arrival airport. That's nice. Let's keep walking through the data set. Okay, this Emirates plane, it's going from Dubai to Pulkovo. Pulkovo, I think this is probably in Russia. Okay, this Austrian plane is also currently flying. It's probably about to depart from Frankfurt to Vienna. You cannot see the blue dot, but it's under there in the departing airport. You can actually, another thing that I didn't mention, you can see here that I was also able to extract the type of plane. So this is an Airbus 321. Oh, okay. All right, let me see. Okay, so it seems like a bunch of these planes were actually in flight right now. This Delta was coming from Heathrow to Minneapolis, and it's actually about to arrive pretty soon. Okay, this Air France also a regional flight from Marseille to Saint-Exupéry. Okay, I didn't think so many of these planes that I selected today would be actually flying at the time of the demo, but this one also going from Berlin to Newark Airport. Yeah, and I think you pretty much get the idea right now. Just gonna finish iterating over all these planes that are currently flying. But this is how you would go about building like kind of a demo airport system. This is kind of a dumbed down, of course, system. It's just getting the registration number and using some APIs to see where the planes are currently at. And that's pretty much it for the demo. Okay. Yeah. So let me jump back to the presentation. Okay. All right, so yeah, thank you all for attending the demo. I hope you liked the kind of this system. I had a lot of fun building it. It was pretty nice to see how from the image of planes, I can automatically know where they are going, where they are heading, where they're coming from and where they're currently at. So there's some links to useful resources here in the presentation. First and foremost, the Landing AI Python package that you can find in GitHub is available to everyone. You just need a Landing Lens API key to be able to use it. So go and sign out to Landing Lens. There's also, so I showed you here the cloud deployment. So basically for this object detection model, I basically just created an endpoint on the cloud that is hosted by us, by Landing, and you can use it with the Landing AI SDK. But if you have other needs, there's also the possibility to do Docker deployment and Landing Edge for manufacturing. All this is local deployment, so you can download the model, run it directly on your computer. Then we have the community, kind of more tutorials in the community of Landing AI. And yeah, if you create an application using Landing AI's models, just feel free to share it in the community, and we will feature you if you build something cool. All right, Adrian.
With that, let's turn this over to our live Q&A. We've got a lot of great questions, so thank you for everyone in our community, our computer vision community, for asking these quick questions. Keep asking them. We're going to do our best to answer as many as we can. So let's kick off with the first one. Which language does Landing AI's OCR currently support, and what other languages are planned for inclusion in the near future?
Yes, that's a good question. So I think I mentioned it in the beginning. I have an example here. Let me go back in the slides to the example here. Okay, wait, here. So currently, Landing AI's OCR model supports just 2 languages. It supports English and Chinese. I think when I mean English, it's not exactly just English text, but more about the English characters, right? So let's say for Spanish, it would probably work pretty well too, for, yeah, and all other languages that use the same character set. And yeah, and then we have Chinese too. There's actually a possibility. So inside our model, we have one model that it's kind of multi-language. It can detect both Chinese and English. But if you want kind of a model to detect specifically just English or Chinese, you can also do that. We have the option, yeah, just to select either or.
Great. Our next question, bear with me one second here. Is OCR the same as text recognition, or is it specified to machines such as scanners?
Yeah, so OCR, it's pretty much text recognition in images. So whenever you have an image that has text and you want to be able to extract the text from that image, that's OCR. I think it's the same. I'm not sure about the terminology, but I think it's the same.
Great. And the next one is, how can we apply deep learning based on OCR in medical images?
Yeah, so that's I think that's a good question. I'm honestly not too into the kind of medical image area myself, but I can think about a couple examples. Maybe so I have noticed that actually in X-ray images, usually there's like in the image itself, there's information about the patient in some place at that image. Let's say, I don't know, maybe very old medical imaging that is not digitalized, and you want to actually start digitalizing this data for your hospital systems. You can actually use OCR to be able to read the patient information or the written information in the X-ray images to be able to digitalize. But if you have any thought about how it could be used with medical images, we're happy to help figuring out how to make it work.
Excellent. Next question. Is Landing AI a free open library?
Yes, so Landing AI Python package is free for everyone. You can find it in PyPy. You can install it with pip install Landing AI. it's free for everyone to use.
Thank you. Next question. Can we use object detection model with labeled data as OCR recognition?
So if I understand correctly, I think you are asking about using an object detection model as an OCR model. I think that's that's not the point of object detection, or that's not how they work best. In object detection, you basically want to group your objects in different classes, right? So for example, detecting airplanes and cars and persons. For example, in the example that I just gave, I'm just detecting the region where the registration number is, but I'm not actually detecting the text with the object detection model. I'm just chaining the two models to then, after I have the region with the object detection model, I'm able to extract the text with OCR. So yeah, it's better to keep those separate. But as I was telling you also in the beginning, and this slide actually helps me again, the OCR model that we offer, which is a deep learning-based OCR model, is able to detect the location of the text. So it's very similar to object detection, but on top of telling you where the objects are or where the text is, it also tells you what's the text inside. So yeah.
Great. Next question. Can landing AI recognize all languages?
Yes, so we don't. We only recognize Chinese and English for now. We are planning to keep improving this OCR model. So it's likely that in the future it will recognize other languages.
Excellent. Let me get to the next question. Give me 1 second here. How many images are needed for labeling and training to make the model have the highest precision of up to 100%?
Yes, so that's kind of the dream, right? We want our models to be perfect, but I think that's never possible. Like I mean, just getting a performance of 100% might be possible for a subset of images, but actually when you go out live with your model and kind of actually use it in real life settings, you will always see that models always make there are always errors with your predictions. The best thing you can do to get rid of those errors is get data that is representative of your live environment, and not just data, but as much data as you can, right? So the more images you can label and the more images you can train the model with, the better the model will perform, especially if those images come from a setting that is very similar to your live setting. So just as much images and labeling as good quality as you can. That's the most important.
Great. Next question. How fast can an embedded camera system read texts like this? Let's assume an ARM6 core running the OCR prediction.
Yeah, so unfortunately I don't have data on like running this OCR model on different hardware. But it depends on different factors. It depends on the input size of the image. So I don't know if you noticed, but when I passed the full airplane images to the OCR model, it actually took a little bit longer than when I passed the small cropped area of the registration number. So there's many factors, and I unfortunately don't have data on the numbers here, but it can be pretty fast.
Great. And then next question, will we have a repo with the code?
Right. So this demo code is not currently available, but I mean, I cannot promise you it will be there, but there is a similar example of extracting the cars license plates in the Landing AI examples folder. Like if you go to a Landing AI GitHub repo, you will find an examples folder with a very similar problem, which is extracting the license plate from cars.
Great. Next one. How can I integrate the model into a web application or into a hardware device to do the job of the model built?
Yeah, so I mean, if you want to integrate it to a web application, you can either like, for example, for OCR, only option we offer right now is using it through cloud. So just you can use it. Actually, one thing that I forgot to mention is you can use the OCR model either through the landing SDK or the landing Python package, or you can use it with just with an HTTP request. So you can just send images through an HTTP request. All you need is an API key from Landing Lens, and that's it. And then if you want to run on device, like on your local device, there's the possibility of Docker deployment. Like you just download like the models from Landing Lens and run them. But Docker deployment is not yet available for the OCR model. It's only available for the object detection, segmentation, classification models from the platform.
Great. Next question. Can we use Landing AI to scan PDF documents?
Yes. Actually, that's possible. You can just send the scanned images to the OCR model, and it will give you back the text.
Next question. Is there an option to train OCR model?
No, so there's no option to train our custom OCR models right now. We offer single one that detects English and Chinese, and that's it.
Camilo, can you hear me? I lost you for a second there.
Yes, Adrian,
Great.
I hear
Okay,
you.
great. Okay, thank you. Next one is, if I use a video file, the video class commonly supports which formats?
Um,
.move. Go ahead.
yeah, so I would have to look through the documentation. I don't remember right now which video formats we support, but yeah, I mean, we do offer a video importer class in the Landing AI Python package. Basically, you just put the path to your video, and we can sample frames from the video to be able to perform inference on those. I think actually there was a previous webinar by Tiago, I think some weeks ago, where he demonstrated how to use the video feed to perform inference.
Okay. Next question. How can be able to introduce text and images without text for the purpose of digitizing medical images? Does that make sense?
Sorry, can you repeat the question?
Yes. How can we be able to introduce text and images without text for the purpose of digitizing medical images?
Uh, sorry, I don't understand the question.
Okay. You know what? We'll do a follow-up with that particular user. So thank you for that question. But we'll probably need a little bit more information. Here's one question. Curious how well it works in airline case when the dim light or night around. Does that make
Yeah.
sense?
That's a pretty good question, actually, and it's something that I also thought about when building the demo. So this demo, of course, very dumbed down, as I was telling you, like to actually get a production system of something similar to what an airport would use, we would need to take into account all these cases. So there's a couple of things. So first of all, if you really have an airport, I'm like I don't know if you have seen, but probably the airport will be very well illuminated all throughout. However, it's true. Like if you don't train a model with images at night, so for example, the region of interest model that I used to detect the registration number, I'm pretty sure that if I send it an image with a plane in night lighting, it will fail. It will not perform correctly because the model didn't have access to data of airplanes at night. But if you just are able to collect the data of airplanes at night, and you are able to see in those images that the registration number is visible, then yeah, I'm sure the model would perform well as long as the images are well illuminated and you have enough label data to train your model.
I think, Adria, we cannot hear you speaking. All right, so maybe next question, I can follow on that. What about semi-transparent object? How many sample does landing AI need to have a correct object detection in a bin, such as a product, like 100,000, 10,000?
Yeah, so I think as I was telling, it all depends on kind of your objective metrics and the quality of the labels that you provide. So in general, a rule of thumb for all deep learning systems is that if or computer vision systems, if you are able to see the images and detect it with your own eyes in the sample images that you have in your data set, then the model is likely going to be able to detect it too. So as long as the images are well labeled and the images are like you can actually detect with your own eyes what you want the model to detect, I'm sure the model can be trained to detect that. And in terms of performance, again, the more images you use, the better. The better labeling quality you have, the better. So it all depends kind of what is your objective and kind of what are the metrics that are acceptable for your use case to be able to determine how many images to use.
Thank you, Camilo. So next question is there any performance spec as how many characters the OCR region per second?
We don't have a performance spec, unfortunately. Yeah.
Let's see. So how would we configure it to work with images of bills to extract, identify specifics? Let's say we want to extract cost and distance travel from the receipt.
Yes. So if I understood correctly, like you want to detect text on receipts. So basically, that's actually a pretty common use case for OCR. It's used a lot to kind of to extract receipt information, extract the final price or the taxes or all the information that you get on a receipt. So yeah, I mean that's a pretty good use case. It's printed data. It's actually similar to also to the slide that I'm showing you. It's kind of structured data, structured text in a certain format where you can actually extract the text. So there's nothing that you actually need to configure if you want to run that. You do need to know your kind of your data, the data that you're gonna pass. So if your receipts have English characters, then you can just load the OCR predictor with English mode available. If your receipts will have both Chinese and English characters, then you just load the multi-language model. It's if you go through the documentation in Landing AI package, you will find how to do this.
Thank you. Next question. They have tried using OCR tool to read the cavity identification number on plastic and silicone mold part. The text and the backgrounds are the same color, so it has been difficult to train the OCR. They encounter issue with a similar character being confused, such as 3 and 8, V and Y, etc. So any idea we can improve upon this?
Yeah. So actually, what this person is describing is a pretty tough use case of OCR. So I'm guessing this kind of a silicon part that just has the text also in silicon. So it's pretty tough. Currently, we don't support, as I was telling you, any customization of the OCR model. But we believe our OCR model is actually very sturdy under different conditions. I think that, yeah, I mean, if you haven't given a try to Landing AI's OCR model, I would give it a try. Again, there's also other things that you can do similarly to what I did for this data set. if you can isolate the area where the text is located, the model will perform a lot better. Yeah, so there's stuff like that you can do, but you cannot customize the actual OCR model, like kind of to train it or to fine tune it with your data. It is not possible yet.
Thank you, Camilo. I think that wrap up our session. So do you mind to put it into our final presentation slide?
Yeah, let me go there.
Yeah, thank you everyone again joining today's session. So as I mentioned, as Adrian mentioned earlier, we will share the recording with the presentation so you can refer back. And we also offer free consulting if you have a computer vision project and wanted to get some advice from computer vision experts. Please reach out to us. So we are happy to connect with you and guide you for your success for your implementation of computer vision. Yeah, with that, thank you, Camilo, for today's session. And thank you, everyone, joining today's session.
Thank you.